A fuel cell is an electrochemical device that converts the chemical energy of a fuel, typically hydrogen, directly into electricity through a chemical reaction with oxygen or another oxidizing agent. Here's a simplified explanation of how a fuel cell works. The basic components include the anode, which is the negative electrode where hydrogen fuel is supplied. The cathode, the positive electrode where oxygen, usually from air, is supplied. The electrolyte, a substance that allows ions to move between the anode and cathode but blocks electrons, forcing them to travel through an external circuit. And the catalyst, a material, often platinum, that speeds up the electrochemical reactions at the electrodes. The working principle begins with hydrogen oxidation at the anode. Hydrogen gas is fed into the anode, where the catalyst splits the hydrogen molecules into protons and electrons. The protons pass through the electrolyte to the cathode, while the electrons travel through an external circuit, creating an electric current. Next, the electrons flow from the anode to the cathode through an external circuit, providing electrical power to connected devices. At the cathode, oxygen from the air is fed in, and the oxygen molecules combine with the protons that have traveled through the electrolyte and the electrons from the external circuit to form water. This reaction completes the electrochemical process. The overall chemical reaction in a hydrogen fuel cell is that 2 molecules of hydrogen and 1 molecule of oxygen produce 2 molecules of water, electrical energy, and heat. The only byproducts are water and heat, making fuel cells a clean and efficient energy source. There are several types of fuel cells, classified by the type of electrolyte they use. The proton exchange membrane fuel cell uses a polymer electrolyte and operates at relatively low temperatures. The solid oxide fuel cell uses a ceramic electrolyte and operates at high temperatures. The alkaline fuel cell uses an alkaline electrolyte and is often used in space applications. The phosphoric acid fuel cell uses phosphoric acid as the electrolyte and operates at moderate temperatures. The molten carbonate fuel cell uses a molten carbonate salt electrolyte and operates at high temperatures. The advantages of fuel cells include high efficiency in converting chemical energy to electrical energy, low emissions since only water and heat are produced, quiet operation, and versatility in applications ranging from portable devices to vehicles and power plants.